Hi, my name is Kendall Karcher, and this is two-factor ANOVA with k at j equals 1. So analysis of variance is used in factorial design experiments where there are multiple independent variables affecting a single dependent variable. In this case, we're going to have two factors. We're going to have factor A as well as factor B, each of them with multiple levels. In this case, they each have 4. And then to satisfy that k at j equals 1, we're going to have a single observation for each combination of factors. And so the two things that we're looking at are sum of squares as well as mean squares. Sum of squares we're going to calculate out for each of the treatment factors, and that's going to help identify what proportions of the variations can correspond to each of the individual treatments. We're also going to use our mean squares, which is the sum of squares divided by our degrees of freedom, to calculate out two test statistics for our two hypothesis tests that we're running here, one for each factor. So in our nulls, we are assuming that our variations are going to be 0 in both cases, one for each of the two factors, and then we are going to reject the null if at least one of these is not equal to 0. So let's look at an example. In the case of an activated sludge wastewater treatment plant, we're going to look at aeration intensity as well as sludge type as two factors that are affecting nitrogen removal. So in this case, you can calculate out the totals and averages for both factors here. And when you run your ANOVA, you're going to get this first initial printout, which is showing some average and variance for each of the rows and each of the columns. And then when you come down here, we're going to look at our sum of squares. So this is our sum of squares for factors 1 and 2 as well as our error. And then we're going to look at our mean squares, which is our sum of squares divided by the degrees of freedom. And our mean squares is what we're going to be able to use to calculate our F values. So our F values are then in an F distribution where we can calculate out the p-value. So in this case, we have two p-values, one for each of the factors because we have two hypothesis tests that we're running. And in this case, for sludge type, we would fail to reject at a normal 0.05 level. Aeration level, we would reject the null. So we can say that aeration level does have an impact on the nitrogen removal.